Hello everyone, this is TSS Zindabad and today we are going to discuss the daily challenge of Leetcode, which is insert, delete, get random in O of 1. So the question says that I have been given this randomized set class and I have to implement these functions. Now let's quickly go through these functions. Randomized set function initializes the randomized set object. Bool insert function inserts an item val into the set if it is not present, and then we return a true if the item was not present, else we return a false. The bool remove function removes an item val from the set if present and returns true if the item was present, false otherwise. The int getRandom function returns a random element from the current set of elements, and it is very important that each element must have same probability of being returned. We need to implement all these functions in O of 1 time complexity. So this is the problem statement for today. Let's talk about the approach. Okay, talking about the approach, the brute force approach that comes into my head is, I'm not talking about the time complexity directly right now. We'll come to the time complexity. First, let's talk about what is the most initial thing I can think of. Or is this something this implementation related to? So yes, I can see that I have a data structure known as set, which almost does the very similar to what is asked. It has an insert function, it has an erase function, and both these functions have a time complexity of O of 1. There is no random function in set. We do not have any random function in set which can provide me with a random element. We do not have that as inbuilt function, right? So regardless of that, I still have two things which I can cater from three of my functions that I need to build. So I think I can talk about this for a while and understand that how can this concept be further used to completely solve this problem and how this is also a solution. Okay. So talking about using the set data structure, it becomes very easy. For example, let's take an example and try understanding it. This is the example that I have, right? So for the time being, let's assume that we are just performing the insert and the erase operation. So these will occur as it normally occurs in a set, right? We can use something like empty function to know if the set is not empty, right? And all these will deliver what is required. Now coming on to, as we do not have any inbuilt random function in set, how will be solving this if I have to use a set data structure? So when I talk about something like random, we have a rand function that is in the STL C++ libraries, which can be utilized. So this rand function provides me with a random element. And now how can I use this? I cannot use it directly, right? And what I want is, let's look in the question. I want to return. So it's an integer value that I want to return. Okay. And it matters, the state of the set at that point of time matters, because as you see, we are continuously inserting and removing something over the period of time. So what I can do is I can use something like a next pointer, right? And I can provide it with a range. And here in the range, I can use something like a rand function, which I talked about, which is in the STL library, which can further provide me with a random value. Okay. So how we will be doing it, what is the code for it, we'll discuss all of it in detail. For the time being, assume that I have built a function random, which is giving me a random value by using a next pointer, and I'm providing it with a range. So I see I have completed all the three functions that I need to do. I know the time complexity for the insert and erase function, which is O of 1. Talking about the random function in detail, we look at what is its time complexity when we'll be coding it up. Okay. So for the time being, let's have a quick dry run. So the dry run for this approach, this brute force approach would be, first I have randomized the set. So that means I've just created a set, right? And let's create an unordered set, because the unordered set will give us the time complexity of O of 1. If it is a set, it will have a time complexity of log of n, because it will be storing all the elements in the ascending order. Okay. So after that, I say insert, I get a 1. So it will simply check that if my S does not have 1, only then I need to put it into my set. Now, why is that? That is because my set only stores unique elements, right? We know this property about set, that we have to store only unique elements. So I'll say I'll be getting a value in case of insert, right? So I'll say if I have not found it in my set, that means it is currently not present. In that case, you will simply insert it, right? And you will return true, else you can return false. That no, I do not have it. So what happens through this code is, in my set S, I got a value 1. I move to the next, that is remove. Now it says that do you have 2? I look into my set, I do not see a 2. So I can simply return a false. I'll return a false. I move forward, I get another insert false. I come here, I get a 2. I check, do I have it? No, it is not present. So we'll simply insert it and I'll get a 2 in my set. After that, we get random. Now, as I told you, for the time being, assume we're using the next pointer, and supposedly it is providing me with any pointer, right? Suppose it is giving me 2. So I got 2 as the answer. Next, it says remove, I go to 1. If it is asking me to remove 1, I'll check if my set has it. So set will say yes, I have it. So I'll say okay, simply remove it. So we can use the dot erase function to remove it. And we'll return a true because we have removed it. We had it in the map and we've removed it. Moving next, we get the insert call. Insert says put in 2. But we'll say that 2 is already there in my map. 2 is already there in my set. I can find it. I can find 2 using the find function, as I have shown you through a very small code snippet here. I'll return a false because it is already there, right? So then I'll go to the next function which says get random, and it will give me another random value which is there in the set. Okay, so this is how the set is working. It is completely based upon the actual set implementation. Now I'll quickly code this up, right? And then we can talk about the time complexity of the whole code as well as the get random function. Okay, so this is the given question to me. I can quickly create an unordered set, right, of integer type, let's name it S. In the case of insert, I want that element should not be present, right? So I'll say if S dot find val is equal to S dot end. That means it is not present in my set. In that case, you will insert that value and you will return me a true, else you will return me a false. Talking about the remove function, I want that I can remove only if it is present, and after removal I need to return a true. So I'll say if S dot find val is not equal to S dot end, that means it is present in my set. In that case, you simply remove it from my set and you return me true, else you simply return me a false. Talking about the get random function, here I talked about that we'll be using something like a next pointer. So I'll say return the next pointer and I'll give it the range. The range would be between whatever from where the set is starting, that is s dot begin. And here I'll be using the rand function for generating the random element and giving it an upper bound s dot end. And I think we're good to go. Let's run this one. Okay, there is some error in line number 27. So here, rather than s dot end as the upper bound, we have to give the size of the set. Okay, so it would be s dot size. Let's run it again. And it is accepted. Let's submit this code. And yeah, it is working fine. So let's quickly copy. Okay, so now talking about this code and talking about the corresponding time and space complexity and why this is a brute force solution and not the optimal one is something I'll answer here. So talking about the space complexity first, as we have an unordered set, it will be storing all the elements that we'll be providing. So the space complexity directly becomes O of n. Talking about the time complexity, we know the insert function is taking O of 1. The find function also takes O of 1. The insert function also takes O of 1. So this whole function has a time complexity of O of 1. Talking about the remove function, again, the find function is taking the time complexity of O of 1. Erase function also takes the time complexity of O of 1. So the remove function's time complexity is O of 1. Now talking about the getRandom function. This is very important to understand. Only then you will be able to understand the optimal solution. Basically, you need to understand that set in C++ does not support random access. Okay. And the iterators that we have in set, they are bidirectional in nature. Okay. So as they're bidirectional in nature, so moving the iterator by certain amount takes linear time complexity. So this is giving me a time complexity of O of n, right? Now what is n here? N is basically the distance the iterator is traveling, right? The distance the iterator is traveling in. So this is very important to understand. I'll be adding the C++ links for understanding that how iterators work in set and why the random access is not allowed in set, for you to understand that why this portion of code is working in a time complexity of O of n. So here is the problem. I want a time complexity of O of 1. I do not want a time complexity of O of n. So to tackle this problem, what I can do is, I know one thing, that when we talk about set, right? So set is in the form of tree. Further to implement this, it gets converted into a vector. And then on the vector I'm traversing, so it is taking me O of n. If somehow I directly had a vector in which I could work out directly the random function, then the time complexity will become O of 1. But now let's talk about vectors, right? Before talking about the complete approach, let's generally talk about vectors. When you talk about insertion, it can happen in O of 1 by the pushback function, right? Because we're directly adding it into the vector. We see that we can get the getRandom function also in O of 1 by directly using the return value and the random function for it, providing it a range, and we'll get the answer. But when you talk about the third, which is remove, it is not a O of 1 time complexity. It will take O of n time complexity. So now another question comes into our head, then how is this the optimal approach? It is the optimal approach because we can convert this O of n into O of 1 by simply using some basic things, right? And how we'll be doing that is something let's discuss further now. So I have understood that the above mentioned set approach was not optimal, right? It was not optimal. To get an optimal answer, I'll be using the concept of using an unordered map and a vector. So what I'll be doing is I'll be storing, see, we know that the insertion can directly take O of 1, get random will take O of 1 as discussed above here, right? I've discussed these two things here. Now, how will we tackle the remove? When we talk about the remove function or the erase function, what I want to do is I want that suppose at a point of time in my vector, I had something like 1, 5, 6, 7, 9, right? I had these elements in my vector. Now I want to remove, supposedly I was given, I want to remove 6. I know that I'll be given the value, right? I will not be given the index. So what I can do is I can figure out where my 6 is. I can simply replace it with whatever is present on my last index. You can get it using the dot back, right? I'll get it and I'll replace these two values. So now my vector will look something like 1, 5, 9, 7, 6. You can say basically I swapped them, right? Whatever you need to consider it. So I simply swapped whatever was on the last index with whatever I need to get to remove, right? Whatever my remove function requires me to remove, that value I have found from my vector, right? I have swapped it with whatever was there on my last index, right? After that, what I'll do is I'll simply have something like v dot pop underscore back, and this would be removed. See, why I can do this is because of two reasons. The first one is that the order does not matter. Because I just want the answer, right? Even when I've been finding things in get random, we're inserting things, it does not matter that it needs to be in a particular order. No, it can be anyhow. I want that this needs to be deleted because it was given in my remove functions parameter. So we can do this. The second reason is that as we know, we are implementing something like a set. So we'll always have just the unique values, right? There won't be any duplicates. So this is the approach for the optimal solution. Now what I'll do is I'll quickly code it up so that we can try run that code for the given example. Okay, this was the previous code that we just coded. I'll quickly reset this. Here, what I'll do is now I'll be using two things, an unordered map, and I'll be using a vector int v. So as you know that we talked about that now we'll be able to get all of these functions, that is the insert, the remove and get random in O of 1 time complexity. What I'll do is in the case of insert, I'll say that if m dot find val is not equal to m dot end, that means this value already exists in my map. As we know that it cannot exist twice because we're talking about a set here. So we'll simply return a false. Suppose if it was not present in my map, then in that case, I'll say simply push it into my vector v, and alongside pushing it into my vector v, I also want that you should add it into the map. So it map is storing a key value pair of what is the map is storing the key value pair or what is the value and the index where it is stored. And we'll simply return a true in this case. Now talking about the remove function, we'll come to the remove function again, right? First, let's write the get random function because here I am doing nothing. I'm just using the rand function. I'll simply return whatever is the value at this index, and it will be v dot size would be, we are taking a modulo so that it remains in the range. It works like an upper bound and we will simply get a random, integer which is present in my vector v, and it is taking time complexity of O of 1. Now talking about the remove function, I just talked about that I want that for removing the function, it needs to be there in my map and in my vector. So I'll say that if m dot find val is equals to m dot end, that means it is not present. In that case, you need to return me a false because it is not there present in my map. That means now I need to remove it. So I'll find whatever is present in my last index, right? I'll get it using dot back function, and I'll say you just simply swap these values in my map also, right? And then I want you to basically swap these values, or we can say just do not even swap it. Whatever has, like here we talked about that what I'll do is I'll simply take this 9 and I'll put it here, right? I talked about I'll take this 9 and put it here. So just put it here. It's not important that you go and put 6 also. You can simply just put 9 here also. If you want to use, you can use a swap function also. Take the time complexity of O of 1. So now what I'll say is whatever is present in m dot m val, you put it here and then you simply pop back. Alongside popping back, you also need to erase that value from my map, right? And then you'll return a true. Now let's quickly run this code and see if it is working fine. And it is. Let's submit this. Yes. So I'll quickly copy paste this code and then we can talk about the time and space complexity. And we can also have a quick dry run. Okay. So this is the code and this is the example. Now I'll quickly do a dry run for you to understand what is happening. So we have randomized set. We already have these two things in public. Then we'll go to insert. So we'll say, we'll come here on the insert function. For insert, we have a value of 1. So we'll say if m dot find val is not equal to m dot end, that means that if this value already exists, right? So we'll say no, right now my map is empty. So I'll say, okay, in that case, what you need to do is you need to push it into your vector, right? So I've added 1 here and we'll add this value. I get this. So I'll add this value here in my map wherein I'm storing that 1 and the corresponding thing v dot size is 1 because we have one element, 1 minus 1 is 0. That means we have stored it at which index and which value has been stored. So basically my map is storing a mapping between the value and the index. Then I go to the next call, that is for remove. I come to the remove function and I get a 2 here to remove, right? The value is 2. So I'll say if m dot find is not equal to m dot end, that means it is not present in my map. So I'll say, okay, map, do you have something like a 2? It will say, no, I do not. So what I'll do is I'll simply return a false. Then I get insert. For insert, I get a 2. I come here, I'll find that if 2 already exists, I see that no, 2 is not there in my map. So what I'll do is I'll push it back into my vector v and we'll put a mapping in my map that is 2 and the index would be 1 because the size now becomes 2 for the vector. 2 minus 1 is 1 and I'll return a 2. Then I'll go to get random. When I come to get random, it will simply return me any random value and in this case it is returning me 2, right? Next we'll go to remove and we get a 1. Now I'll check that if it is not present in the map, but I'll say no, it is present. So we'll come to this section of the code. Here, what I'll say is, I'll say, okay, make an integer last and put whatever is in the last. That means the last value in n minus 1 value of my vector v, I get 2. I'll say whatever is the last, right? Whatever is in the last m, that means Whatever is the index here, change it with here. So that means here it will become 0, here it will become 1. Okay. And then I'll say here also in my vector, change these values. So this becomes 2, this becomes 1. And then I'll say simply pop back in my vector. Now I have a vector remaining of only 2. And I'll say erase the corresponding value. So that means this part gets erased. I just have one mapping in my map and just have one element on 0th index in my vector. Next, I go to insert, I get a 2. As soon as I get a 2, I see it already exists in the map. So in this case, I'll not do anything. I'll simply return a false. I've returned a false. Then I'll go and have a random value here. And in this case, I'll get 2. So this is how this is working. Now let's talk about the time and the space complexity. All the functions insert, remove, and get random have a time complexity of O of 1, right? Talking about the space complexity, it is O of n because we are storing each and every insertion, right? So at max and worst case, we can have n insertions. So the space complexity is O of n and time complexity is O of 1. Thank you so much for watching the video till the end. Please like, share, and subscribe. Thank you.